The relation R on the set, the Cartesian product of the set of natural number n with itself, it is defined as the ordered pair A comma B is related to the ordered pair C comma D if and only if A times D equals to B times C for all values of the ordered pair A comma B and C comma D belonging to the Cartesian product is an equivalence relation. So that means R is an equivalence relation. This is given to us, and we need to find out the equivalence class of the ordered pair 2 comma 6. Okay, let us begin. So here we have a relation R which is on the set. The Cartesian product of the Cartesian of the set of natural numbers itself simply means that R is going to be a subset of the Cartesian product of n with itself. Then we have the relation R that is given to us. The relation R is such that this is going to be a set of ordered pairs. So we are going to consider the ordered pairs A comma B as well as the ordered pairs C comma D such that, and they has to belong to the Cartesian product of n with itself, such that A comma B, this ordered pair is related to the ordered pair C comma D as A times D equals to B times C. Fine. Now, what is A times D equals to B times C? In other words, it is simply the A comma B equals to C comma D. In other words, what we have, if we consider the ordered pair A comma D, that gives us the fraction A over B, and the ordered pair C comma D is such that we have the first element dividing the second element, giving us the fraction C over D, and we're seeing that both of these two fractions are equal. So that's what we are writing it as AD equals to BC. Now, using this, we need to find out the equivalence classes of 2 comma 6. Okay. Let's begin. Now we'll use the definition. The equivalence class of the ordered pair 2 comma 6. This is simply defined as the set of ordered pairs x comma y, which has been picked up from the Cartesian product of the set of natural number with itself, such that with the condition that x comma y has to be related to the ordered pair 2 comma 6. Okay. Now, using the definition of the relation, what we have is, we have the set of ordered pairs x comma y belonging to the Cartesian product of the set n with itself, such that since we have x comma y related to 2 comma 6, in other words, we are saying that x over y, this must be equals to 2 over 6. Let's cross multiply to get 6x equals to 2 times y. Now, both of them have factors of 2, or this can be also expressed as 3x equals to y. So here we have y equals to 3x. So this is how x and y are related. Now, using this, we can now find out the set of ordered pairs. So if we choose x to be equals to 1. So what we're doing here, we're choosing x. See here, x and y are both natural numbers. Meaning, if we choose x to be equals to 1, then the corresponding y value, that's going to be equals to 3. Then, if we choose the next natural number 2, so 3 times 2, so we have 6, so 2 comma 6. Next, if we choose x to be equals to 3, then we have y to be equals to 9. So if we choose x to be equals to 4, then 4 times 3, that's 12, and so on. So this is going to be the equivalence class of the ordered pair 2 comma 6. In other words, what we are saying here, so if we consider 2 comma 6 the ordered pair 2 comma 6 simply refers to as, take the first element, which is 2, and divide it by the second element, that is 6. This gives us a fraction 2 over 6. We're saying that this is going to be equals to the other fractions. That means this is going to be equivalent to 1 over 3. This is going to be equivalent to 3 comma 9. Then this is going to be equals to 4 over 12, and so on. In other words, we are saying that these are all equivalent fractions. And that is indeed a true statement. Now, this is how we can obtain the equivalence classes of 2 comma 6.